Every year, hundreds of millions of old vehicles are dismantled. But the most valuable part is often not the engine or the body. It is the wheel assembly. Behind those worn-out rubber tires and twisted aluminum alloy rims is a billion-dollar recycling industry, built to turn automotive waste into polished, fully finished wheel assemblies for the next generation of vehicles. To make that possible, the tire is restored through retreading technology, extending its service life by tens of thousands of miles without the need to manufacture a completely new tire. Meanwhile, aluminum wheels covered in scratches and deformation are shredded, melted down, and transformed into entirely new rims. In this video, Factron Process follows the complete journey of turning scrap into value. From the dismantling yard to the moment a fully rebuilt wheel assembly reappears on the production line. You may not realize it, but in the era of green industry, recycled wheel assemblies are no longer just an alternative option. They are becoming a practical direction for the modern automotive industry. Recycled aluminum alone can save about 95% of the energy required to produce new aluminum from bauxite ore, while also reducing a significant portion of greenhouse gas emissions. Meanwhile, more than 250 million end-of-life tires are generated every year in the United States alone, and roughly 79% of them enter recycling or reuse markets. That is why old wheel assemblies today are no longer viewed simply as scrap material, but as a strategic resource for a cleaner, more affordable, and more sustainable manufacturing chain. And perhaps that is the most fascinating part of all. Something that once reached the end of its journey in a scrapyard can now continue rolling down the roads of the future. When a vehicle reaches the end of its service life, it is delivered to the intake area of a recycling plant. Here, technicians record the vehicle identification number, or VIN, the engine number, year of manufacture, overall condition, and all related paperwork. They also photograph the vehicle, attach a tracking code, and upload the full data set into a digital management system. This stage not only allows the entire process to be closely tracked, but also creates the basis for assessing the remaining value of each vehicle. The inspection focuses on components that can still be reused, such as the engine, transmission, electronic systems, and interior parts. Usable components are separated and supplied to the multi-billion-dollar used auto parts market. Meanwhile, vehicles that are severely damaged or completely worn out are sent directly into the dismantling process for material recovery. Once this stage is complete, the vehicles are organized into designated zones across the storage yard, lined up in a clear and systematic order before entering the processing line. Few people realize that in the United States, more than 95% of end-of-life vehicles pass through this system, making automobiles the most recycled consumer product in the world. Thanks to this level of organization, each vehicle can maximize its recoverable value and continue contributing back to the economy. Once the vehicles enter the dismantling area, they are lifted using hydraulic lifts or specialized support systems. Here, technicians use high-powered pneumatic impact wrenches to remove all the lug nuts securing the wheels. In just a few seconds, each complete wheel assembly, including the tire and rim, is separated from the suspension system and lowered either by hand or with lifting equipment. Because these assemblies contain valuable amounts of rubber, steel, and aluminum alloy, they are usually collected separately immediately after removal, instead of being sent with the vehicle body into the shredding line. This is also the starting point for the recycling journey of millions of wheel assemblies every year. After being removed from the vehicle, the wheel assemblies are transported to the tire separation area. Here, each wheel is secured onto a tire-changing machine, while a technician uses a specialized pry bar to work between the tire bead and the rim flange. As the wheel rotates around its central axis, the tire bead is gradually pulled over the metal rim until the entire tire is separated from the wheel. Although the principle is relatively simple, this process must overcome the extremely tight bond between the tire and the rim, a connection designed to withstand thousands of miles of driving without slipping off the wheel. Within just a few minutes, a complete wheel assembly is separated into two distinct material streams, ready for their respective recycling processes. Once separated from the rim, not every tire is destined for shredding. Some still retain a carcass, the internal load-bearing structure of the tire, that remains strong enough to serve through another life cycle. Rather than being destroyed, these tires are sent to a retreading line, a process that can extend their service life by tens of thousands of miles while using far less raw material and energy than manufacturing a new tire from scratch. The process begins with a detailed inspection of the carcass. Technicians look for visible cracks, cuts, and deformations, while chirography technology is used to detect hidden defects within the tire's internal structure. Only carcasses that meet strict safety requirements are approved for further processing. Next, the approved carcasses are placed into specialized buffing machines to remove the worn tread completely. High-speed grinding heads shave away a thin layer of rubber while restoring the tire's roundness and roughening the surface in preparation for the new tread. The amount removed is typically only a few millimeters, just enough to eliminate the old rubber without affecting the tire's internal load-bearing structure. In the retreading industry, this is considered the most critical stage, as the quality of the buffed surface can determine up to 70% of the bonding performance between the new tread and the existing carcass. Once the buffing stage is complete, many defects that were previously hidden beneath the worn tread begin to appear, ranging from nail punctures to small cuts and cracks. Technicians remove the damaged rubber and then restore the carcass using liquid rubber, hot rubber compounds, or specialized repair patches. After the repair work is finished, the surface is buffed again to create a smooth, uniform structure that blends seamlessly with the rest of the tire. Some facilities also employ electronic inspection systems or X-ray technology to ensure that no hidden defects remain within the carcass. Only those that successfully pass every inspection and repair stage are approved for a second life. With the carcass restored and certified, the tire moves into its most critical stage, applying a new tread. In the pre-cure method, pre-manufactured tread strips are bonded to the carcass using a layer of uncured bonding rubber. In contrast, the mold cure process wraps raw rubber directly around the carcass before shaping it inside a mold. Regardless of the method used, precision remains essential, as even a minor deviation can affect the tire's balance during operation. According to many retreading specialists, the quality of the tread application process plays a major role in determining the service life and overall performance of the rebuilt tire. In the final stage, the tire enters the vulcanization process, often considered the cooking phase of the entire operation. Before being placed into the heating chamber, the tire is wrapped in a specialized rubber envelope, combined with an airtight inner tube. This outer layer acts like a protective shell, distributing pressure evenly across the surface while preventing air from entering during curing. Once inside the curing chamber, temperatures can exceed 400 degrees Fahrenheit, while high pressure forces the new tread to bond tightly with the existing carcass. The heat causes the rubber's polymer chains to reorganize, creating strong cross-links that increase durability while preserving flexibility. After several hours, the result is a rebuilt tire with sharp tread patterns that can be difficult to distinguish from a brand new product. But the process does not end there. Each tire undergoes a series of rigorous inspections, including dynamic balance testing, detailed surface examinations, and even X-ray scanning to detect hidden defects. Only tires that successfully pass every inspection stage are approved to leave the production line, ready to deliver tens of thousands of additional miles of service. While the tires are being restored, the old rims begin a very different journey. After being separated from the tires, the wheels are collected and transported to specialized metal recycling facilities. Here, thousands of steel and aluminum alloy wheels from various sources are gathered into large batches before processing begins. Wheels that once endured millions of rotations on roads and highways are fed into powerful metal shredders, where alloy steel cutting shafts gradually tear them into smaller fragments. Reducing their size makes the material easier to transport and sort, while also significantly increasing the surface area exposed during the melting process. The shredded material then passes through a series of separation systems that sort steel, aluminum, and other metals into distinct streams. By the end of this stage, what remains are clean alloy fragments with relatively consistent material composition. Although they no longer resemble their original form, they still retain nearly all of the material value contained in the original wheels. These metal fragments will become the feedstock for the melting process, where the true rebirth of a new wheel begins. The alloy fragments recovered from the shredding and sorting process are then transferred to melting furnaces to begin their journey of rebirth. Inside the furnace, the aluminum is heated to approximately 1,300 to 1,400 degrees Fahrenheit until it becomes completely molten. However, producing a new wheel is far more complex than simply melting metal and pouring it into a mold. The alloy composition must be carefully monitored throughout the process because even minor variations in elemental content can affect the wheel's strength, impact resistance, and long-term durability. During melting, lighter impurities rise to the surface as dross and are periodically removed, leaving a cleaner and more uniform metal bath beneath. Thanks to its ability to be recycled with virtually no loss of material properties, aluminum has become one of the most valuable materials in the modern automotive recycling industry. Once the molten metal reaches the required temperature and composition, it is transferred to the casting area. Here, heat-resistant steel molds are sealed and prepared to receive the liquid aluminum. Rather than pouring the metal rapidly, many modern systems introduce it into the mold in a controlled manner to ensure that every internal cavity is filled evenly. The molten aluminum flows through a network of channels, reaching the outer rim, mounting surface, and the complex spokes that define the wheel's structure. At this moment, the shape of a new wheel begins to emerge after its long journey through dismantling, shredding, and remelting. Over the next several minutes, the mold's cooling system gradually extracts heat from the metal. The aluminum transitions from a liquid to a solid state and begins to retain its final form. When the mold opens, a newly cast wheel emerges with its rim, spokes, and structural features fully formed. It is difficult to imagine that only a few hours earlier, this material existed as worn and damaged wheels, covered with scratches and deformation. Through recycling, the energy required to produce a new wheel is dramatically lower than that needed to manufacture aluminum from raw bauxite ore, while the material itself continues on to serve another life on the road. After casting, the wheels are transferred to CNC machining centers for final finishing and precision shaping. Every bolt hole, mounting surface, and rim edge is machined according to digital design specifications to ensure consistency across all products. By the end of this stage, the original casting has been transformed into a fully finished wheel with all the required technical specifications. Before leaving the production line, each wheel undergoes a series of rigorous quality inspections. Sensors and laser measuring systems check roundness, concentricity, and dimensional variations that could affect performance on the road. Many manufacturers also use X-ray technology to detect internal porosity, microscopic cracks, or other hidden defects that cannot be seen with the naked eye. Only wheels that successfully pass every inspection requirement are approved to move on to final assembly with recycled tires. Once both the retreaded tire and the recycled wheel have passed their individual inspections, they are brought together in the assembly area to become a complete wheel assembly. Here, the wheel is secured on a tire mounting machine, while lubricant is applied to the tire beads to reduce friction during installation. Hydraulic pressing arms and specialized rollers then guide the tire beads over the rim without damaging the newly restored rubber or the finished metal surface. Although the process appears straightforward, the applied forces must be carefully controlled because the tire and wheel are engineered to form an exceptionally strong airtight seal once assembly is complete. After mounting, the wheel assembly is inflated to the specified air pressure, forcing both tire beads firmly against the rim flanges. Sensors continuously monitor pressure stability to identify even the smallest leaks that may occur at the interface between the tire and the wheel. Assemblies that meet the required standards are then transferred to a dynamic balancing machine. Here, the wheel is spun at high speed while sensors analyze mass distribution around the entire circumference. A difference of only a few grams between locations can generate noticeable vibration when a vehicle is traveling at highway speeds. To correct this, small balance weights are attached at precisely calculated positions until the wheel reaches proper balance. With this final step completed, a new wheel assembly is born. What makes it remarkable is that its two most important components both originated from materials once considered waste. One side is a tire reborn from an old carcass, while the other is a wheel created from recovered alloy. After passing through extensive restoration, recycling, and inspection processes, they are reunited as a complete system, capable of meeting the durability, airtightness, and stability requirements needed for real-world operation. So the rebirth journey of a wheel assembly comes to an end. From worn-out tires and scratched, damaged wheels removed from old vehicles, a series of restoration, recycling, and inspection processes have transformed them back into a complete system capable of serving for many more years. It is also a perfect example of how modern industry maximizes the remaining value of materials rather than allowing them to end up in a landfill. If you enjoy exploring large-scale industrial processes like this, be sure to subscribe and join Factron Process for more incredible manufacturing and recycling journeys. And now we'd like to hear from you. Which automotive component do you think has the most fascinating recycling process? Let us know in the comments below.